Perfect.
Okay.
The floor is yours. Thank you.
Is the full screen now?
Yes, it is.
Okay. Hello, everyone. This is Yuning Zhang. I am a PhD student from the University of China. Today, I'm glad to present our latest research about the working paper, the impact of COVID-19 crisis traditional recovery package on China's economy and energy consumption based on input-output analysis. This working paper wanted to seek for the impact of difference between the green recovery and the old mode in China after the pandemic. Let's take a brief review of the global green recovery. First, the European Green Deal recovery package is expected to allocate hundreds of billion euros to investment in sustainable mobility, renewable energy technology, and clean hydrogen. As for China, the central government has announced to firmly support new infrastructure construction in response to the downturn caused by COVID-19. The concept is similar to EU Green New Deal and covers digital transformation such as 5G network, big data centers, AI, and industry internet, as well as some low-carbon industry routes such as intercity, high-speed railway, ultra-high voltage for renewable energy transmission, and charging infrastructure for electric vehicle. Investment in these 7 fields would improve the efficiency in both production and the consumption process, which means a positive impact on decarbonization. This is obviously different to the recovery package of the finance crisis. However, new infrastructure heavily relies on national companies and the private group because there is a lack of sufficient investment from the central government and a shortage of project reserves from local governments. In this way, we talk about the situation about the new infrastructure. Today, new infrastructure heavily relies on national company. So in this way, for stimulating economy, the size of coal power projects promised by local governments have exceeded that of last year. Based on the background, we hope to estimate the impact of new infrastructure construction on China's GDP, energy consumption, and CO2 emissions. And then we want to compare it with the results by assuming China entirely uses the post-2008 simulate again. Let's talk about the method. We choose the Mizanzawa extend input-output model instead of common saving-closed input-out model because this method considers the marginal consuming tendency, so we could not only estimate the GDP size, but identify its share between rural and urban groups. To achieve this goal, we use the data from China Neighbor Statistical Yearbook to disaggregate the value-added metrics in non-competitive input-output table in China. In addition, sector-rate energy use and CO2 emission intensity are also calculated by using latest China Energy Statistical Yearbook. Now, according to the cost component of various new infrastructure, we can disaggregate the investment side into IO sectors for each item of infrastructure of the new. Scenario design for the report from CCDI group with government background. We calculated the total size of new infrastructure is 12 trillion RMB, and the investment will be allocated to the period from 2020 to 2025. Key sectors such as electronic machinery sector, computer and communication sector, low carbon sector. So we said the BAU is a scenario that it is a post 208 simulators, similar scenarios. The results. Because of the time delay or time lag effect of investment conversion into capital formation, GDP in both scenarios shows an invert U-shape feature, and there is a longer investment period in NIP. So GDP peak time will delay from 2021 to 2025. Total GDP is close to 14 trillion RMB, with about 2 trillion less than that in BAU. The reason may be that in NIP and BAU scenario, electronic sector and the construction sector are priorities respectively. But the former value-added rate in IO table is 60.3%, with about % smaller than the later one. What's more, it is interesting to note that the urban units account for 80% of GDP in both scenarios. In the NIP scenario, the imports also improve. There is a lack of comparative advantage in computer, communication, and electronic sector. The import size is about 1,500 billion RMB, which exceeds the whole size of BAU. Increase of imports also explains the reason why GDP is smaller in NIP. Energy consumption. In terms of energy, annual and total energy consumption in NIP shows a more friendly pathway, accounting to about 500 million ton standard coal equivalent, compared to about 600 million ton in BAU. Considering energy efficiency improvement in the future, energy consumption in NIP is expected to be lower. As for the fossil energy use, the consumption size slightly decreased in NIP, while there is no clear trend of change in energy structure. We note that the proportion of coal is still large because, to some extent, the investment structure overlaps into the two scenarios. So, in addition, IO analysis has some limitation in analyzing energy substitution and simulating technology innovation in the long term. The CO2 emission from energy combustion. The total emission in NIP is close to about 1,000 million tons, which is about 230 million tons less than that in BAU. CO2 intensity also declined by 7.9%. The trend in both scenarios also consistent with the change of GDP, and the percentage of emission from coal combustion close to about 19%. We care more about the sector characteristics about CO2 emissions. As for CO2 emissions component in sector, although production and supply of power and heating is still the largest emitter, it contributes to the most emission reduction to NIP. The share of emission from construction sector only reached 5.65 million tons. Non-medical mineral product sector emits less in NIP, even though its high-related sector such as computer and electronic product sector has a massive investment size. This result indicates that the reduction governance and technology advance in power and heating sector is very important, even though there is no investment in this sector under both scenarios. So, in summary, this paper estimates the impact of China's different recovery packages on economy, energy consumption, and CO2 emissions. The path of new infrastructure and traditional recovery is significantly different, even though their calculation value is close. New infrastructure lasts longer, and its GDP growth rate has a flat inverted U shape. Urban units account for about 80% of GDP, driven by new infrastructure. Energy consumption is about 100 million standard core equivalentness in new infrastructure. In this way, making CO2 intensity decrease by 7.9%. Thank you for your attention.
Yeah, thanks a lot, Yuning, for this very, very interesting presentation. And we do have times for questions on your presentation, also for discussion. Now, when we discuss, unfortunately, we cannot speak, but we can use the Q&A function here to put down some general points, and then I can channel those to the speakers. And also the speakers, you have the opportunity to reply in writing to those questions, because you see those in the Q&A. So let me look whether I have some questions here. Yeah, while people think about questions, Yuning, let me ask a question to you. So your new infrastructure
Yes.
scenario, what are the assumptions? What the key assumptions that makes it different from the business as usual, as you call it? And in the business as usual, is there any recovery package there as well, or is this just no recovery package? Just the economy play out.
Okay, thank you for your question. The BAU scenario is assumption scenario. We accept that the recovery package is same as China's post-financial crisis package. It is known that China in 2008 invested about 4 trillion RMB in high carbon sector, but in 2020, the pandemic of COVID-19, we want to launch the new infrastructure to do the same work. So BAU is an assumption scenario, and we want to set it as a baseline.
Mm-hmm. Okay, and the NIP. So is that, you said new infrastructure? Is that has this a green component, or is this more related to the Road and Belt Initiative?
Sorry, I can't. Could you repeat this question again?
So in the new infrastructure scenario, when you say new infrastructure, what exactly do you mean with new infrastructure? Does it mean green infrastructure? It doesn't mean digitalization? Does it mean both?
They mean both, because you can see this slide. We think this time China is launching the new infrastructure, and this key sector are low carbon sector, such as the 5G network. It is have a high related to the computer and the communication sector, and this is a low carbon sector. In new infrastructure related sector are both green and high tech sectors.
Okay, great. Thank you.